Yeah, good morning, everyone. Today we can discuss a few key topics. This key topic we may not see directly in the SQL Server, but throughout the classes, and it's a core concept of the SQL Server, and it will useful entire the like data. If you talk about the backups, if you're talking about the performance, if you're talking about the index removal, and if you're talking about any locking and lock escalations, and any corruption, data storage, those areas, if you want to better understand, then we have to understand these concepts. Okay, so this directly we cannot show the practical, but it's a kind of a theoretical knowledge how the data is arranged and storage. Okay, so now we can go for a kind of a some storage structure. In that storage structure, we can talk about the some key points. Okay, the let me go for the SQL Server how the data is stored. Okay, let me go for storage structure. If you go for storage structure, like first we can go say like a records. Then I will explain one by one on by. Then we will go for pages. Then we'll go for ext and extends. Then we'll go for files. Then we'll go for database. Let me- oh, Yeah. So the storage structure, whenever the users, whenever the developers, whenever the business entering into the data. Okay. So if you go for any kind of a on sites like online links like a Google, like a Flipkart, Amazon, whatever it may be, whenever they entering the data has to come from the database. So actually, the data has to come from database, right? So like the person or users knows only this username and password, and when they enter, they will click the radio button. Once the radio click button, what will happen? The- In the background, it will initiate the lot of API packages and some other information using the structure query language. It will interact with the database and it will get the data. But before, uh, like the data is getting, but the data is stored in the database. But initially, the data where it is stored, further, then where it will go to store. So whenever the data is entering, the data will be stored in the form of records. So whenever the user is entering the data will be stored in the form of records. So whenever the user is entering the data will be stored in the form of records. So those records we can call like a raw data. So generally people will telling raw data, raw data. What is the raw data means like it is a collection of records. The records is nothing but a, whatever the data entering, that data we can call like a raw data. So the records will be stored, right? So thing is like records are entering. Like records is nothing but we have a rows. Come on. So the data, like we can think like the data entering like rows, but there should be some sufficient limit, right? The thing is like in the Gopher database, the data will store directly in the database, all right? It will be stored in the table. Okay, the data will be stored in the table. The table having like a uh, we have a rows and columns. Okay, so actual data stored in the records. Uh, but if you keep on entering, how long the data has to store? So initially the data will be stored in the records. The all the records grouped together into the one location. Let me give you exact definition. Don't confuse us. Yeah. So in the SQL Server, all the data will be stored in the form of uh, records. These records we can call as a raw data. All these records further grouped into a page. So now we are going to discuss about the page. So before going to discuss about the page, we need to understand what is the record. The record is nothing but the in the SQL Server internally the background, the every data the user is entering, that data will be stored in the form of rows. That rows we can call as like a row data. In the further, all the rows are grouped together into the page. So why? Because there should be some at limit, right? So suppose I have a building. In that building, we can have a like a separate rooms. In that separate rooms, the room will be stored this much of amount, but the room size will be vary. Like one bedroom, this much of size, and like a master bedroom and a kitchen, like a children bedroom, like that. But each bedroom having a some certain limits. But coming to the SQL Server, uh, uh, like the rooms and array like a place, it should not be like a different. All the rooms should be same storage. Like master bedroom, like a 100 square feet, and a kitchen like a child bedroom like 10 to 14, uh, different, right? But coming to the SQL Server, whatever the data we are entering, that data will be stored in the background, but one certain limit data stored, then it will go to the next location, next storage. Okay, that storage also it will be maintain the some consistency kind of a bytes. Okay, so the data like the storage how will come like bytes, kbs, gbs, then kilobytes like tbs, right? Terabytes. So initially the data will go like a bytes. So each hand room will be some certain of a storage. So now we are talking like a storage and some certain of a byte, right? So here that storage area are a specific place we can call like a page. Okay. So now the page, the meaning is the fundamental unit of data storage is called a page. So interview. they will ask, okay, what is the page? The the page definition is the fundamental data unit of storage is called page. So now the thing is like before going to the page, we need to understand the record. As I mentioned, record is nothing but the what are the data entering into uh, the, the data will be stored in the form of records. That a the data we can call like a raw data. Further, all records grouped together into the one page. So as I mentioned, the it's a fundamental unit. The fundamental means like if I have one page that have one storage space, if I have one more page, that should be maintain the same storage that may be fill or may not be fill. But what are the area we are giving? That area should be maintain same consistency of the uh, space. Okay. So now the definition is the fundamental unit of data storage we call like a page. So now if you come into the page, uh, as I mentioned, the records group put together into page, right? So whenever we entering the data, the all the data storing into the page, no. So the page also can be dividing into the three parts. The data is coming to the records will be stored into the page. So the entire page will be stored the records. That is the scenario. Like we can tell the entire the page it cannot store the records. Why? Because the page is divided into three parts. So let me go for the page diagram. So this is called like a page. So now this page is dividing into three parts. This page into dividing into three parts. So like as I mentioned, the records will be stored in the page. Let me take. Okay. So the page dividing into three parts. Whatever the data we are entering, the data will be so initially what I mentioned, what are the users entering the data will be stored as a records. Those records group together into the one location that is called page. So what are the users entering? Those enter into the page, but this page having divided into the three parts. So in that three parts, only one part will store the actual data. Okay. So now the page having three parts. One is page header, HADR page header. This is the call like a data records, and this is called like a row of set array. Okay. So uh, this page having, like as I mentioned, what is the page? The the fundamental unit of data storage is called the page, right? So the page having some size. What is that size? So as I mentioned, the each page will be maintaining into the same storage, right? So the page size is around 8 KB, not around, it's a fixed. It's a 8 KB. So what is the fundamental storage unit? That is 8 KB. So each and every page, the data like the storage is 8 KB. So in that entire 8 KB will be stored what are the user is entering? No. So the page can be divided into three parts. The total size of the page is 8 KB, and the page can be divided into three parts: page header, data records, and row offset. So here the the page header itself takes some storage. So the page header will take how much storage? 96 bytes, and a row of set which will take how much? 2 bytes. So now we can convert into the 8 KB. So in that 8 KB, the total size is 8 KB. In that 96 bytes goes to page header and 2 bytes goes to the row of set array. Remaining storage will be stored the data records. So what I meant to say here, 8 into 1024 bytes minus 96 bytes minus 2 bytes. What are the value is coming? That value is stored the actual data. Actual data means like what are the users are entering the data. The data will be stored in the after taking out of from the page header and row of setter. Remaining storage will be stored the actual user data. So now the data records will be entering the users. So here what exactly the page address contain and what exactly the row of setter array. Why? Because it is taking some storage, right? So if you think like a one page, the page header and row of setter. But if you go for I have like a 1 TB, I have a 10 GB. So then we have to go for bytes, right? So if you one page is 96 bytes, if you say 10 page means 10 into 96 bits, that much of storage unnecessarily wasting, right? If you thinking like that, but actually that will also having some useful information about the our data. So directly like if you want to know the this page information, okay, so think like a you have a apartment. In that apartment you have a 10 rooms. In that rooms, if you directly go to that room, we don't know, right? So by look, if you maintain the some key like the board, the by looking at the board, we'll come to know this room belongs to this person, this room belongs to uh, 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 a particular area, like that the page header, it will tell what is the this page. So the page header having multiple like some kind of information. What it will tell, the page header consists of what this page ID. So each and every person having one like identification, right? Like every person having a identification, and every data will be identification. But the thing is like here also in the while entering the data, it while uh, if you have a number of like a huge amount of data, the data will be stored in the form of page, right? So while storing the data, it has to recognize, right? How it will recognize? By looking at the page ID and page type. So we can discuss another 5 to 2 minutes the page types. So the page header, it will contain the page ID and what is the page type, and uh, what are the data storing, sorry, what are the data storing, which object the data is going to store, and header of the this page version. So 96 bytes allocated. This 96 bytes goes to the page ID and page type and page version. So internally, the page will maintain this data because whenever the data is coming, the SQL server has to identify the data, which page it has to go, and uh, and which object it has to store. So by looking at the page header, the SQL Server database engine will understand the data records he has to store this page or different page. So that is the purpose of the page header. So now, what is the purpose of page header? Means if they ask, we can tell the page header, it contains the page ID and what type the page it is and what objects it's going to store, and uh, some other information about the page. So now we understand for the page header and the data records. So the data records, the user entering the records. Then here, what is the purpose of the row of set array? So here, uh, the another thing is like what is the purpose of row set array. So now we understand page header because it definitely required to identify the what is that page and what is the page id, and what is the object id, what is the object id it is going to store, and the data records is for the what are the user is entering the data is storing in the this particular area. But now what is the row of set array? So the row of set array, it will be bottom of the page. Let me, I have some collected data. Yeah. So what is the row of set array? It's a directory at the end of the page. It's kind of like a directory, and it uh, containing the end of the page. So what will happen? It's kind of like a mini index. What is the mini index? The thing is like I want to access the where it is stored. 1 minute. Let me. This is not. Just now I wrote the diagram. Right. Sorry. Where it went. Come on. Here only. So row of set array. It's a end bottom of the page. It's kind of a directory. So if I want to get the data, okay, if I want to get the row of the like records of the this particular page. So in this scenario, what it has to do is suppose I have a 20 records. Okay, I have a 20 records. I want to get the one record of the data. That scenario, what it has to do, it has to scan entire the record set. So that will be taking longer time. So if you maintaining the pointers of the that particular record. So what you mean to say? Records. So whenever entering the data, if you maintaining the a pointer or location of the data, it's no need to scan the entire data. By looking at the row of set array, they easily identify the record. It will fetch the data. So that is a reason a row of set we can call like a mini index of the page, and it will contain the pointers of the data where it is stored. So the row of set is a data directory, and it will contain the pointers the where the data is stored. If you want to get the data, it's no need to scan the entire the page. By looking at the row of set array, it will fetch the record. That is the purpose of the row of set array. And one more thing is like I enter the data. So the data will be like 20 records. I deleted the data. Okay, if you deleted the data, empty space will be arranged, right? So that time, no need to rearrange the data. Just you have to update the row of set array. That will be taken care from the SQL Server. So now you understand about the page, and in the page, what exactly the field will contain. Let me go for one more uh, uh, quick recap for the page. Then we'll go for the page types. So what is the page? Why? Because it's a interview question, and as well as the further, as I mentioned, it's very important to understand the indexing part. Okay, and as well as the backups. So the page is nothing but the fundamental unit of the data storage is called is a page. The page size is 8 KB. In that 8 KB, 96 goes to page header, and 2 bytes goes to row offset array, and the remaining data will be go to the actual data. Let me give the actual Microsoft definition. Yeah. So the same. SQL Server is the fundamental unit of data storage and IO operations. IO must is like a read and output, input and output operations. Input means like you're entering, output we are getting. Input output operations. All the data within the SQL Server database is logically divided and stored into these pages. So if they ask any someone questions, you can tell the answers. The page is the fundamental unit of data storage. The page size is 8 KB. So you mentioned like each page in SQL Server is a fixed size of 8 KB. Now they convert it into 8192 bytes. So then 8192 bytes, and you have to tell the again answer. Like in the page can be divided into three main components: page header and row data row area and row offset area. The page header containing the information about the page, that is what is the that page number, what is the up type page type, and how much amount free space that page having, and also this page belongs to which object. So the page header, as I mentioned, it will contains the mere component of the page header. Suppose the page header is corrupted, then entire page will be useless. Why? Because the SQL Server not able to identify this page belongs to which data and which objects. So that is the reason page header is very important, because it will keep the or store the critical data. Under data row area. So this is the where actual data rows are stored. So 8K page space allocated to this area. So this data row is what are the users are entering, that data will be stored in this area. So row of set array located at the end of the page. This array entry contains 2 bytes entries of each row on the page, indicating that starting position of the each row. The starting position means like it's kind of like a pointer, the where the data is storing. That will tell the page. Okay. This is the page definition. Now we'll go for the what page types. So you have to just read it and get more knowledge. I think this information is sufficient. So if the anyone is asking, directly go for what is the page and what is the page size. Yeah. So directly you can give the answer what is the page and page dividing part, and you have to explain what is the page header and what is the data row and what is the row set array. So now here what I mentioned here, the page header we can tell like a, what is the uh, uh, about the page such as a IDs. So about the page means like we have a different of a pages. Okay. So if you ask the count, we have a 8 pages, but we should not tell always the count of the pages. Why? Because if you forgot to explain any one of the page, the interview look for the another page. What? Because they will count your answer. So that is the reason you can tell the answers, the page, and from once the explanation is done for the page, then you have to start the like we have a number of pages. You always should not tell the how many pages we have, the count we should not tell. Now let me go for the page types. Okay, so if you go for the page types, we have a number of pages. Here they mention only few, but we have a 5 to 6 pages we can tell. So one is the database. 1 minute. Yeah. So one is the database and another one is the index space. The another one is a test or image space. And we have a another pages called like a index allocation map or IAM pages. So here the thing is like one more pages like a index allocation page and IAM page and GAM page. Let me go for not here. The page types. Page types, database, index page, then test or image page, then go for then uh, free space. What is it? Free space page. Then one more is GAM page. Then free space. Okay. Index allocation. Then GAM page. Then BCM page. This is a very important BCM page. And then one more is DCM page. One more IM page. So we have a page is a boot page, but it won't a kind of a it's a undocumented. We can discuss about the boot page whenever the people are asking. No need to give the boot page. It's a not kind of a storage. It's kind of a voice level kind of information. But people will expect what is the boot page. So if anyone asking, you have to give the page types. Uh, Page types are database and index page, test or image page, free space page, and GAM page, and BCM page, DCM page, and IM page. So here I mentioned the page, right? So we, these pages are have this kind of a different pages, and each page will having 8 KB. So the data page also is stored 8 KB, index page also stored 8 KB, test image page also stored 8 KB, free space also stored 8 KB. Why? Because it is a fundamental. It is not going to change for the page type, one page type to another page. So all page types are stored in the 8 KB. But that may be stored into the multiple pages based upon the object. So GAM also storing into the 8 page, BCF BCM page also stored into the 8 KB data, DCM page also stored into the 8 KB data, IM page also 8 KB data. So here, what is the purpose of the database? So the database is mainly for using the whenever the people are entering the data. So as I mentioned, the actual raw data kind of like a, if you maintaining the go for any bank, the bank actual data is our data is like a salary, like our bank account number, and as well as our amount data and transactions, right? Those are the actual data because those are entering from the user perspective. That is the that data will be storing into the database. So the database will be used for what are the users are entering the records. So simple definition, shortcut definition is stores the data entered by user. Let me go for here. Stores the actual data of the row tables. So except a large object data. Okay. Anyway, test next image is going to the test pages. So the only the data page used for to store the data row of the table that rows entered from the user. Now one more page is called index page. What is the purpose of the index page? So in the, when we created the table, uh, when we storing the data will be storing in the inside the logical in the tables, right? So if you the data is storing into the tables or a database, if you want to search the data, if you want to insert the data, if you want to select the data, so that time suppose I have a 100 records. Okay, if I want to get the uh, 700 records, so that time what it has to do, it has to scan entire the like kind of a what I meant to say, it has to scan entire the all the records. So that will be taking longer time, right? So what it will do, it will maintain one more page. That page will point into the where the data is storing. So the index, the pointers will tell where the data is stored. So so here we are maintaining the index rate. So maintaining also we required some storage rate. So that is the reason what are the indexes we have, what are the giving the storage, that index information it will be stored in the index space. So the index space store the index entries to facilitate the efficient data retrieval. So here I have a data, but if I go for here to scanning, if I want to get the data from the, suppose here I have one page, no issues. Suppose I have a 100 pages, and in that 100 pages, which page and which record if I want to get it. At that time, what it has to do, it has to scan entire all the pages, right? That time what will happen, our data will be taking longer time. So if you maintaining an index, that data will be retrieve very fast. So why? Because the index will pointing to the actual data where it is stored. So that is the reason we are maintaining the indexes. So maintaining the indexes that also required some storage, right? So that is the reason to maintaining that area, we require one page. That page we can call like a index page. Now we'll go for the another test imager page. So generally we should not store the index like images or a test in the uh, where the data is storing. So that time images or a text should be stored into the different page. So those kind of information will be stored into the text or image page. So generally like when you creating the uh, table or some other things like they will they will mention LOB data types. Okay, large objects things. So that time the data images and pages will be stored into the images pages, not for the data pages. So even though the images are belongs to users, but the images will be stored into the test or image page. So now I hope you understand for the what is the database and what is the index page and what is the LWV page. Now we can go for one more page called like a GAM page. GAM and SGAM. So GAM and SGAM we can discuss here where it is GAM and SGAM. Here they did not mention. We'll discuss GAM and SGAM. We'll discuss. Before that we have a go for the uh, we have one more page called BCM page. So one the BCM page. So the BCM page also very important. The very important means like whenever a huge modifications, bulk operations happen, at that time the SQL server has to maintain those bulk operations is going to modify the which pages and this belongs to which extent. So the BCM page will maintain the track of the bulk operations or those bulk operations are like what are the pages are going to modify. So in the BCM page, it is not storing tracking the information about the page, but it will track the information of the extent. So yeah, I can explain now what is the extent. Okay, then we'll go for the these things. So the what I mentioned BCM page, right? The BCM page is telling what are the bulk operations are happening. That time it has to modify, it has to enter the number of pages. Okay, so but it is not tracking the pages. Instead of that, it will track the extent information. Okay, so here what is the extent? It also very important. Okay, what is the extent? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. One is a vector scheme. Okay. So here what is the extent? So extent is nothing but a group of 8 pages we can call like a extent. So uh, if you go for here, the storage architecture, what I mentioned, records, the pages and the extent, right? So when we're talking about the BCM page, the BCM page, it will store the what are the page or modifications, those modified extended information it will stored. So extent is modified means the background, the modification of the pages. Why? Because extent is a collection of 8 pages we can call a extent. So I have a 8 pages. This 8 pages we can group of 8 pages we can call like a extent. So extent is nothing but a extent. So extent is a group of 8 pages we can call like a extent. So each extent having 8 pages. So that may be index page or that may be database or that may be what you meant to say uh, d- uh, uh,
BCM.
BCM page and DCM page, like we have different pages, right? So the extent have different pages. But the thing is like here, extent you have a two kind of a extents. So extent we have a two extents. One is extents are two extents. Uniform, uniform extent, next extent. So here extent is a group of 8 pages we can call like extent. These extents are uniform extent or mixed extents. What is the uniform extent? Uniform extent means like a I have a one table. Okay. Uh, that uh, table will store the one particular object. So what are the data is storing into the entire 8 pages belongs to one table. Okay. So what are the pages are allocating to the one object, not for the other objects. So that time that extent we can call like a uniform. Uniform is like it is maintaining and it is storing the for entire one object, not for the another objects. Maybe that objects may be required another extent, but what are the pages? 8 pages. This 8 pages are belongs to one object. That extent we can call like a uniform extent. And what is the mixed extent? So the mixed extents is nothing but uh, kind of a different of objects. So suppose what are the 8 pages? That may be one or more objects. Like 8 pages belongs to two objects or more than two objects. That time this extents we can call like a mixed extents. So they will ask the interview question, can you give more uh, information about the extent? So suppose we have a table called like A, and what are the table having uh, table A, the table storing into the 8 pages. That 8 pages belongs to table A. So that type that time that extent we can call like a uniform extent because the entire page are belongs to the table A. But mixed extent means what are the pages in the 8 pages? One page belongs to table A and one page belongs to table B. A remaining page may be A or may not be B or maybe some other objects. So that time that extents we can call like a mixed extents. And one more thing is like whenever the extent is creating, that time every page it will go to the mixed extent. Why? Because uh, generally uniform extent it won't formed. The one whenever the extent is creating, that extent will go for the mixed extent. Okay. Why? Because it will be stored into the different of objects. Once the entire pages are filled in the background, SQL server will rearrange the pages. It will make like a uniform and it will make like a mixed actions based upon the number of pages and objects. So whenever the new page is going to create, that page will belongs to the mixed extent. Okay, that is the funda of the background storage. So now where we are in the BCM page. So the BCM page means it will track the record information about the extent. So that means in the directly indirectly it will tracking the page information, but it is not going to store track the all the pages. So this may be index page, this may be database, this may be some other page, but it will track only external information. Okay, the BCM page, it will track the which extent is going to modified. That will track from the BCM page. Now we'll go for the one more DCM page. So this DCM page is also very important. Okay, using the this DCM page, our one of the critical backup.
Hello, Adi, your voice is not audible.
Oh, sorry, it's a like it went to mute. Sorry, sorry.
Can
Now,
you
now it's okay.
explain again?
Yeah,
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 can you explain again?
yeah. So we are talking about the DCM page. Okay. I hope you understand for the BCM page, right? So now we are talking about the DCM page.
Okay. Yeah.
So the DCM page, we it will important and it is very useful when you're talking about the backups. Okay. So the DCM page will be comes to the picture in the differential backup. Okay. The why? Because the backups we have several kind of backups: full backup, differential backup, and log backup, and other kind of backups. But the thing is like we have one critical backup called like a differential backup. So while taking the differential backup, what will happen? This DCM page, what it will do? We have a full backup taken. Okay, I will explain in detail for the full backup. Let me go for here. The full backup taken. So after full backup, what are the pages? What are the pages are modified? Okay, and what are the extents are modified? Those information will stored in the DCM page. So we have taken the full backup. After taking the full backup, we can. So the thing is like uh, the data will be always comes to the page. It will modified and it will update. That is fine. But the thing is like whenever we want to take the differential backup, okay, that differential backup, how it will take the data? What are the data is modified after full backup? Okay, how it will recognize? It will recognize from the DCM page. So the DCM page is not going to store entire data. It is going to store the information about the what are the pages and what are the extents are modified after taking the full backup. So generally the people will fall under impression, think like that TCM page, it has the entire data. The data is modified after full backup. That is not correct. The DCM page, it will track the information about the pages or extensions which are modified after full backup. Okay. So using that DCM page, the differential bill backup will take. So whenever we're taking the differential backup, what will happen? The SQL server look for the DCM page, then it will go to that particular pages and extend, and it will take those page backup. So the people what they will think, they will take the DCM page backup. That is not correct. It will look for the DCM page. Then by looking at the DCM page, it will have the all the information. What are the pages are modified and what are the extensions are modified. Using that pages directly, it will go and pick those pages and extended information, and it will storing into the location which are giving to the user. So the DCM page is like the DCM page track the information about the pages which are the extent and which are pages are modified after taking the full backup. That is the purpose of the DCM page. So now the BCM page is for the bulk operations. DCM page for the what are the pages are modified after full backup. So it's very important. The interview I'll ask definitely when we go for the backup definition. They will ask what is the differential backup and which criteria the differential backup will come to know. Uh, what are the data it has to take, what are the pages are modified after full backup. So that time we have to tell the DCM page will maintain the all the track record, what are the pages are modified and what are the actions are modified after full backup. Using the this page, it will go to the that particular page and it will collect the data and it will keep the as a backup. That is a BCM page purpose. Now we covered data page and index page and test page and BCM page and DCM page. So here what is the free space page? Free space page is nothing but it will tell what are the pages having free space. So simply it maintaining the data about the pages. So which page having how much free space we have. So so that means I have a 10 pages. In the 10 pages, which page having how much free space that particular page. So the free space is nothing but it won't store any user data. It won't store any index space. It won't store any BCM page. It stored only about the which page having free space, how much it has that page having free space. That is a free space. Now we can talk about the GAM page. So it's a very important the GAM page. So the GAM having two types of GAMs. One is uh, here 1 minute global allocation map and shared global allocation GAM. So GAM and SGAM pages. Okay, GAM and SGAM pages. So global allocation map and shared global allocation map. I have given recently explanation for a previous class. So this is an interview question. Okay, let me give. Yeah. So what is the GAM? It tracks which sections are completely free. So here, what is the purpose of the GAM means like it will tell about the what are the 8 pages are available. So here, come on, come on. Yeah. So the GAM it will tell what are the 8 pages are free. Okay. But coming to the SGAM, it will tell about the mixed extents. So the GAM it will tell about the information of the uniform and mixed extent information. But SGAM it will tell about the only for the mixed extents. Let me go. Okay. So the GAM, it will tell about the 8 pages free. What are the 8 pages are it will free? Those it will tell the GAM. But SGAM, it will tell for the only mixed extent information, which page having like which extent having free storage. So that means each extent having 8 pages, right? In that eight extents, is there any free space available for the page? That will tell the yes GAM. GAM, it will tell what are the 8 pages are available. It will tell why, because if you have a large object, we have in that scenario, while allocating the large objects, it has to allocate the uniform extent, right? Why? Because that large extent object definitely required more than 8 pages, and it will generate the uniform extent. Let me go for theory. That is understood. Yeah. So here the purpose of it tracks which actions are completely free. All 8 pages are available, and so it will track whenever you allocating the new extents for uniform extents allocation. Why? Because whenever a new object is creating, that object required more than 8 pages. That time, what will happen? It will generate the uniform extent. Okay, that extents it will track from the GAM page. So now coming to the SGAM. So SGAM is the track about the mixed extent information. Why? Because that mixed extent, it will track only for the it will store the different of objects. I have a small object that won't require uh, more pages. So definitely, instead of allocating the uniform extent, it will look for the mixed extent. If you have any free space or not, if you have any free space, that page will go to the mixed extent. So it is important for the interview, they will ask. So what is the GAM page and what is the SGAM page? Can you give the difference? So we can tell like the GAM, it will tell about the information about the extent information, and the SGAM, it will tell only about the mixed extent information. In the GAM, it will tell about the uniform extent, what are the 8 pages are allocated, and SGAM, it will tell only mixed extent, and in that extent which page is available to store the data. The GAM will come to the picture whenever we have a bigger object. That time the SQL Server has to allocate the 8 pages. The 8 pages will come to the uniform extent. Why? Because if you have a small page, that won't require 8 pages. That required only 1 or 2 pages. So instead of allocating the new extent, that will go to the mixed extent. So using the SGAM, it will the data will be stored into the mixed extents. So the basically the fundamentals tell the GAM and SGAM tells about the extent, which extent having the free space. The GAM, it will tell about the uniform extents. In the SGAM, tell about the mixed extents. These are the important for the GAM and SGAM. Let me go for one more page. IAM page. What is IAM page? Let me double check and confirm, because we have an index page and the IAM page. There should be some difference. I don't want to give any fault data for the I don't want to confuse index page and IAM page, because both are related to index. Okay. I will double check and give you the difference for the index, and IAM page. So right now we are pending for the IAM page and boot page. Remaining pages are we are covered. Okay. So let me recap for the today topic. What is the row and what is the page and what is the extent and and in that page what exactly the data will be uh, dividing into the how many parts and what is the purpose of the page header and what is the purpose of data records, what is the purpose of row of set array, and we discussed about the extents and the types of extents, and we discussed about the page types and pending for the IAM page. So next Saturday, we can discuss about like installation and as well as the storage like SQL Server architecture, and if possible, I can compare the architecture for the Postgres as well, so that in the background you people start learning Postgres as well. So if you understand the architecture of the data, how it is going to store, the parallelly you can start googling from the your side, you can start learning Postgres. But if you want to start Postgres, you need to understand the Postgres architecture as well. So Sunday, next Saturday and Sunday, what I'm going to do, I'm going to explain both SQL Server installation and as well as the Postgres installation, and I will give the architecture of the SQL Server, uh, how data is storing and how the data is storing Postgres. But coming Monday onwards, fully we can concentrate about the SQL Server. But end of the class, I can give the Postgres or some related data. Okay. Let me stop the recording. I hope you understanding for the pages. It's very important. I will share the recording as well, but I need your email ID so that I can send the this particular data to the private link. Let me stop it.